Imagine you're standing right here, right now. The ground beneath your feet feels solid, stable, but it's not. Not really. You're actually hurtling through space at 1,000 miles an hour. That's the speed of Earth's rotation. At the equator, faster than any bullet. Now, picture this. Without warning, without a single tremor, the planet just stops. Dead still. What happens to you? You, that coffee cup, the building behind you, the entire city? You don't just tumble over. You become a projectile, launched eastward at supersonic speeds. We're talking about being slammed into a brick wall at Mach 1.3, and you're not alone. Every single thing not bolted directly to the bedrock or in the very slowest parts of the poles becomes a kinetic missile. Cars, trees, skyscrapers, even the very air itself. Cities would be erased in an instant, reduced to shrapnel. But that's just the beginning. The truly apocalyptic horror starts when you look beyond the immediate impact. Because what happens when something the size of an ocean keeps moving? When its container suddenly halts? The oceans. Oh, the oceans. They don't just splash. They become world-ending tsunamis. But how exactly does a planet just stop? And if it did, what would the new stationary Earth even look like, let alone feel like? Because the answer involves everything, from the air you breathe to the shape of the planet itself. To understand what happens when Earth stops, we first need to get a grip on why it spins in the first place. Think about a figure skater. When they pull their arms in, they spin faster. When they push them out, they slow down. That's angular momentum in action. Our planet, like everything in the cosmos, got its spin from its birth. Billions of years ago, the solar system was just a giant cloud of gas and dust. As gravity pulled all that material together to form the sun and the planets, the whole system started to rotate faster and faster, much like that figure skater pulling her arms in. This initial spin is baked into the very fabric of Earth. It's been doing it for 4.5 billion years, a constant, silent engine of our world. Newton's first law of motion comes into play here. An object in motion stays in motion unless acted upon by an external force. And the Earth? It's a massive, incredibly complex object, spinning like a top. The energy stored in that spin is monumental. So, what kind of force would it take to just kill that momentum? Even something as powerful as a collision with another planet wouldn't necessarily stop it cold. It would probably just change its axis or speed. This isn't a simple brake pedal. This is like trying to stop a freight train by holding up your hand. It's a fundamental violation of the physics governing our planet. But for the sake of our apocalypse scenario, let's assume it does happen. Instantly, the ground you're standing on, remember, is moving at 1,000 miles per hour. When it halts, your own inertia carries you forward. So, everyone, everything, above 100 feet of latitude from the poles gets violently ejected eastward. It's like a colossal car crash. Everywhere, all at once. For reference, the fastest roller coasters barely hit 150 miles per hour. This is literally 7 times that. Imagine the impact force. Buildings are sheared from their foundations. The very ground, not just you, but the actual soil, rocks, everything would be ripped away by friction and momentum, a global, cataclysmic debris field. But here's where it gets truly wild. The atmosphere, the air itself is also spinning with the Earth. If the solid ground stops, the atmosphere doesn't. It keeps going. Think of it, a planet-sized bubble of air, still rotating at 1,000 miles per hour, scraping across a suddenly stationary surface. This creates an unimaginable global superstorm. We're talking winds that make a Category 5 hurricane look like a gentle breeze. These winds would be supersonic, literally eroding mountains, scouring continents bare. Anything that survived the initial impact would be sandblasted into oblivion. The entire surface of the Earth would be stripped, reshaped by a tempest of unthinkable power. And those oceans? Oh, the oceans. This is perhaps the most visually terrifying part. The vast bodies of water, driven by their own immense inertia, would slosh across the continents with terrifying force. Imagine a tsunami that isn't just a wave, but the entire ocean basin moving. The sheer volume of water moving eastward would scour the land, tearing apart everything in its path. It wouldn't just be coastal regions. It would sweep inland for hundreds, even thousands of miles. Eventually, this colossal liquid momentum would settle, but not evenly, because the Earth isn't a perfect sphere. Its spin causes it to bulge at the equator and flatten at the poles. like a slightly squashed basketball. If the spin stops, the centrifugal force that creates that equatorial bulge vanishes. Over time, the Earth would settle into a more perfect sphere. This means the water, no longer held in place by the rotational forces, would migrate. It would flow from the equator towards the poles. So, within days or weeks, the equatorial regions would become massive, arid supercontinents, completely devoid of water. Meanwhile, the poles would be under oceans thousands of feet deep. Imagine the land masses of North America and Eurasia merging into a singular, vast, dry plain. While the Arctic and Antarctic become oceanic abysses, it fundamentally reshapes our world's geography. Then there's the perpetual day and night. With number rotation, half the planet would be plunged into eternal darkness, dropping to hundreds of degrees below freezing, a frozen wasteland. The other half would face perpetual sunlight, baking under an unyielding sun. Temperatures would soar, evaporating any remaining surface water and rendering the land a scorching desert. The atmospheric pressure differences between these two extremes would create monstrous, constant winds, distinct from the initial superstorm, as air frantically tries to equalize the insane temperature gradient. Could anything possibly survive? Perhaps microbial life, deep underground, far from the surface chaos. Maybe, just maybe, some hardy organisms in the narrow band of twilight, where the sun finally sets for good, might find a way. But what about Earth's protective magnetic field? What happens to that if the core, which gives us our magnetosphere, suddenly isn't spinning anymore? Our magnetic field, which shields us from lethal solar radiation and cosmic rays, is generated by the molten iron outer core, churning and flowing, creating a geodynamo. If the Earth's rotation stops, it would likely disrupt these currents over time, potentially weakening or even collapsing our magnetosphere. Without that shield, the planet would be bombarded by radiation, making even underground survival incredibly difficult, sterilizing what little might remain. It's an apocalyptic scenario on every conceivable level. This isn't just about things being inconvenient. It's about the fundamental unraveling of the physical processes that make Earth habitable. The good news, if you can call it that, is that such an event is astronomically improbable. The amount of energy required to halt Earth's rotation is almost incomprehensible. Nothing we know of in the solar system, short of a direct, perfectly aimed collision with a rogue planet of equal mass, could possibly do it. And even then, the outcome would be more about a new, mangled planet with a different spin, not a dead stop. So, for now, we can rest easy knowing our planet will keep spinning, carrying us safely through the cosmos. But thinking about Earth suddenly stops isn't just a fun, dark thought experiment. It's a powerful reminder of how finely tuned our existence is. Every day, the simple act of Earth's rotation provides us with a stable climate, the rhythm of day and night, and protection from the harshness of space. It's a silent, constant miracle we rarely acknowledge. It makes you wonder, doesn't it? What other cosmic constants do we take for granted that if just slightly tweaked would unravel everything we know?